Hey everybody, welcome to another video. This is the first video in the fourth sprint, and in this video I'm going to be explaining how we will be creating clustered indexes and unique indexes in the next video. This is going to go over how indexes or how clusters look when they're on the primary key and why we will not be doing that, and you will see how we normalize the physical model in this master data management system. So hope you like it. Clusters or indexes in general are extremely important pieces for speed optimization, and what a better way to start the sprint. I'll see you after the title. All right, so before I get into the keynote, I want to talk about what happens when Microsoft SQL puts a default clustered index on a primary key. So what I have right now is just a couple of random tables with about 6 rows each. And if we order by the primary key, all of our tables are going to become defragmented. So we have multiple tables on the same page. If we assume that 8 rows is a K, which in this case it's not, but just, bear with me. Everything's defragmented. So to avoid this, what we want to do is in our clustered index, we want to make the specific data set number the first column in all clustered indexes. And that's going to force SQL to physically order the data on the same pages and the same sectors of the drive. So not something I could really demonstrate in the specific data set number video, but definitely something I can demonstrate now. So in this video, we're going to be entering data to create data-driven indexes. So piecing together or ripping apart the syntax is we have a create what index followed by a name. Now we're going to be using 2-letter abbreviations to fill out the abbreviation in our index name, just like SQL does, except for we're taking a different path because I believe their cluster column store is CCI or something. So we just want to leave it at 2, easier to reverse engineer. And the index name really only exists on non-clustered indexes, so we're going to bypass that entirely in this episode because non-clustered and cluster column store indexes are really custom indexes. We can only have one clustered index, and there are more row-based clusters than column store clusters, so we're going to mark those as custom. And we're just going to focus on the common indexes in this video and in the next video. Essentially, we have declared our definition, clustered, unique, non-clustered column store, etc., our type of index, and our family of common and custom. So that being said, let's continue to pull apart the syntax. What we have in all of our indexes is on what table and what column should we include. So the way we're going to go about doing this is just have a list of data point types, because we're going to link a definition to a data point type again, and say, when I'm in the family table, I know I have a specific data set number and a taxonomy ID. When I'm in a base table, I know that I have one of these things that I can work with. And when I'm in the shared, at least I know I have a specific data set number, a foreign key parent, and a taxonomy ID. So just by knowing that and using the definition of data point relationship type, we can kind of do a where in and order them. And for the non-cluster indexes, we do have an include, but that's part of the custom piece, and we're going to wait on doing that because we want to create more data-driven code before we set up processes, and that's why we have a definition of process relationship that will gather the data to create our custom indexes. And the last piece to the SQL code is the file group. And in order to create the file group, we need to know the subject type and the dataset type and what index we're using. So the very last piece of the file group, the suffix, cluster, columnar, index, those will be the definition. The definition will tell us where or what file group our data should be stored on. And if our dataset type is in base or shared, we're going to want to use the subject type, and that will let us know should this data go on the group file group, the relationship file group, or possibly the reference file group if we have declared types of data or subjects as reference types. And all of our realm class family types are or will be considered reference data because they're small and they don't change, so they'll always be on the reference file or reference file groups. So that's how we're going to build the file group and get it returned. So in this video, I'm just going to kind of show you how I set up my definitions for common index, clustered, and unique, and then how I related those to the data point types and then put them in my system relationship table. So I love using sheets, and in one of my sheets I have my definition for clustered and my definition for unique, blue and purple respectively. And then I have my data point types. I just copied all the types that I had and went through it and say, hey, what do I want in my blue cluster or purple unique? And what I came up with was for the cluster index, I know I need parents, taxonomy, or cluster IDs because, you know, sometimes one of those are not there. I need my specific dataset number because that'll be the first one. And I need my implied primary key and specific dataset number implied for the relationship tables because I want to make sure that I'm clustering on those keys to bring the relationship types together a lot closer. And then for my unique index, where there is a parent, I'm going to let the root idea is to have a unique name and key name combination. We can reuse the same key name and sort of do this implied funneling technique, which we'll go over a little bit later in the series, but really the tenant and the name and the key name is what we're looking for. However, when you introduce the TaxonomyId, different slices of data, or the ClusterId for realm, you can run into duplicates, and we don't really want to limit ourselves. So what I'm doing for a unique key is in the cases where it's not a relationship, we're going to have the name, tenant, parent, and TaxonomyId. And in the cases that it is part of the relationship, well, we won't have the name, the key name, and we won't have the parent, so it'll just be the tenant who owns the data, both implied keys and the type of relationship, which should be more than enough. So relating them together, like I've done in previous videos, I just edited the system relationship table, copied a row, pasted it in sheets, kind of filled out what was necessary. And you'll notice that I put a sequence column there. We do have a sequence in our system relationship, and I made it red on the screen. And I ordered those in the way that I want them built. But for the unique index for the purple code, I don't really need an order for them. So I just left those null. Same code's gonna work, but we really, we have a unique index, and then we have our cluster. So I just inserted all this data into my relationship table to get all this set up, because in the next video, we're gonna create code that will access this data. But that is about it for this video. Thank you very much for watching, and I hope you enjoyed. Remember, like this video and YouTube will recommend it to other users, and subscribe to support me. Next video, we're creating the code that will create all unique and clustered indexes that we need. I'll see you next time.